Go. All right, guys, so we're looking at lesson 2.1, and this has to do with functions and their graphs. The first thing we're starting off with are some definitions. The first definition is the definition of a relation. A relation, guys, is a set of ordered pairs. Now, of course, I will be sharing this video with you later on. So if you miss out on anything, you can just go ahead and see this later. Now, when we name a relation, guys, typically we use a capital letter to name it. So this relation here, I'm going to call it relation A, and it will have the following points in it: 3, 2, 2, 0, -1, 2, and perhaps a -2, 2. All right, I'm making this up as I go along, guys. Now, when we talk about a relation, guys, remember we're talking about a pair. So the pair that makes up the relation, guys, they have specific names. So there are 2 sets of elements. Those two sets of elements includes the domain and the range. So let me go ahead and erase this so I can go to the next page. Let me let some people in here. And so on this one, guys, the first set of elements in a relation is referred to as the domain. The domain is the first set. I'm going to rewrite it again, okay? Hold on. The first set of elements in a relation. As in, guys, all the x's, okay? All the x's. Not all your x's, but all the x's, sugar plums. Okay, I'm calling you guys sugar plums. Why am I calling you sugar plums? You're not in my high school classes, okay? So all the x's, guys. Now, the domain is next. I mean, the range is next. When we talk about the range, guys, here, let me put x over here for domain. And for range, we're just going to put y on here so you guys can remember this. This represents the second set of elements in a relation. So when we talk about the second set of elements in a relation, you could refer to them as all the y values, all the y's, guys. So this is a quick and easy way to remember this. Now, when we talk about the XY plane, think of the XY plane, guys, in terms of alphabetical order. So X comes before Y alphabetically. So when you plot a point in the XY plane, it's always in the form of X, Y. So likewise, if you're talking about domain and range and you're having a hard time remembering which one is which, think alphabetically. Alphabetically, domain comes before range. So therefore, you would equate domain with X and range with the Y. Similarly, if we're talking about a horizontal line versus a vertical line, alphabetically, horizontal comes before vertical, and so horizontal would equate to X. Horizontal has to do with X. Think about the X-axis. Vertical has to do with Y. Think about the Y-axis, guys. And then one more for those of you moving on to the upper level math courses, when we talk about sine, cosine, the trig functions, guys. Cosine alphabetically comes before sine. So cosine is synonymous with X and sine is synonymous with Y. So this is a great way of remembering what's what when it comes to the XY plane. So guys, I am going to go back to relation A again. These were the elements in relation A. We had 3, 2, 2, 0, -1, 2, and then -2, 2. So now that we have our relation and we know what the domain and the range represent, I could go in here and ask you, what is the domain of this relation? In other words, what are all the x's in this relation? So we just list out the x values, 3, 2, -1, -2, and just like that, you're done. Now, guys, be careful. If you have a repeated element, you can only write that repeated element down just once. So for the range, guys, the range which represents all the x's in the relation, I mean all the y's in the relation, y, okay? If you go into relation A and you want to list the range of relation A, it would include the elements 2, 0, and then that's it. Why? Because the 2 is repeating. So when you have a repeated element, you can only include it once. So guys, be careful with that when you're going through the assignment, okay? Now, there are multiple ways for you to express a relation here. Multiple ways, multiple forms, okay? Multiple ways to express a relation. So besides the fact that you can list a set of points, other ways you can go ahead and express a relation, guys, is through what is called a table, okay? And in this instance here, I'm talking about the T-table, T-chart, however you want to say it, it really doesn't matter, okay? So you might see something like this. This is a display of a relation, another way to represent a relation, guys. So you've got a table with a whole bunch of points on it. This is also referred to as a relation. We could use a graph, guys, on the XY plane. So if you go to the XY plane and you plot a whole bunch of points in the XY plane over here, let's say I'm gonna plot a point, and you know what, let me go ahead and put some marks on here, okay? And then I'm gonna plot some points on here. So here's a point, here's another one down here, and then last but not least, I'm gonna have like one right there. So that's a relation as well. A graph is considered to be a relation. An equation, guys, is also considered to be a relation, such as y is equal to 2x plus 3. Now, another way to express a relation, guys, is through a word problem, an application problem. That's also an additional way to express a relation. And then last but not least, sometimes you will notice a mapping. When we talk about the mapping, basically we take the set of elements, as in the domain and the range, we map them onto each other. So if, let's say, this represents a domain and this represents the range, the domain has the elements -3, 2, -1, -2, and then the range has the element 2, 0. We have to show which element in the domain is paired up with which element in the range. So we use these arrows to show that. So we're saying -3 is mapped onto 2. Okay, 2 is mapped onto 0, and perhaps -1 is mapped onto 2, and then -2 is also mapped onto 2, okay? So those are the elements that are being paired together. So guys, these are the various ways we could express a relation. Now, next part of this, guys, is a function. Could you explain the mapping again? Okay, let me recap this. Let me see here. Bring this back. Okay, there we go. The mapping is just another way for you to display the relation. You see how I have the relation in the table right here? And the domain has the elements -3, 2, -1, -2. That's what's in the first oval right here. So the first oval represents the domain. And then the second oval represents the range, and the range had the elements 2, 0. So that's my range. Now I have 2, whoever's reading this, inform them which element in the domain is paired with which element in the range. So the -3 is paired with the 2. The 2 is paired with the 0, okay? And then the -1 is paired with the 2. So another way of saying this is to map. The 1, the -1 is mapped to 2. The -2 is mapped onto the 2 as well. So this is another way of expressing the relation. Now, guys, additionally, one key definition we look at in this is the definition of a function. This is what this section is about, guys. A function is a relation. Remember, we just mentioned what a relation is. We saw various forms of it where each element in the domain is paired with exactly one element in the range. Now, guys, as a reminder, let me do this for you. Range is Y, domain is X. So for each X value, there's exactly one Y value. So in other words, the domain, that's your X's, guys. When we talk about a function is a relation where the domain does not repeat. The domain doesn't repeat, as in the X's will not repeat when you talk about a function, guys, right? Now, I am going to go ahead and move back up to that relation we were talking about earlier, relation A, guys. Now, relation A had the elements -3, 2, 2, 0, -1, 2, and -2, 2. So if I were to ask you, is the relation a function? Is relation A function? You would look at the domain, guys. As long as the domain doesn't repeat, it's considered to be a function. So let's look. And remember, we're just looking at the domain. So just look at the X's. So look at the X's. Do you see anything that's repeating? Are any of the X's repeating? As long as they're not repeating, it's a function. So this one, yes, it's a function, guys. It's a function because the domain doesn't repeat. Now, while I'm here, let me go ahead and mention, guys, the inverse. This is the notation for the inverse of a relation. And we're going to see this at the end of the chapter, way at the end of the chapter, guys. So when we talk about the inverse of a relation, guys, we're looking at swapping. We are swapping X and Y. So X becomes Y, Y becomes X. Later on, I will explain to you why we swap the X and the Y. But for now, guys, if I have this relation up here and I were to ask you, what is the inverse of the relation? You would just go into the relation and swap X and Y. So that -3, 2 will become 2, -3. The 2, 0 will become 0, 2. The -1, 2 will become 2, -1. And of course, the -2, 2, will become 2, -2, right? So now, guys, the reason why I bring this up is to ask this question. Is this relation a function? Is the inverse of the relation a function? Again, look at your X's. Look at your X's. Are they repeating? Yes, we have repeated X values. So because the X values, the domain is repeating, this one would not be a function. So it's not a function because the X's are repeating. All right, guys. So any questions about this one right here? Remember, I like questions. You can drop them in the chat, guys, or you can go ahead and turn on your mic and have a conversation with me. Now, guys, here comes the next part. Given an equation, and yes, you will see a question like this on the test. Given an equation, you have to determine, you have to decide if it is a function of X. Is it a function of X? Given a relation, given an equation, is it a function of X? For example, guys, I'm going to show you these two equations. X squared plus Y squared is equal to 2. Versus number 2, which is Y equals to X squared. Now, I'm giving you these two side-by-side equations because one of them is a function and one of them is not. So if you're looking at these two equations carefully, you will notice there's one minor difference, which makes a major difference in the outcome. There's one minor difference, but it's going to make a major difference in the outcome. What is that minor difference? Here it is, guys, right there. This Y is squared, and this one right here is not, okay? So as a result, number 2 is a function. However, number 1 is not. Now, how do we know number 2 is a function and number 1 is a function? How do we verify this? How do we show this? Here's how we show this, guys. you want to go ahead and solve for y. Solve for the y, isolate y, get the y by itself, okay? If y is equal to a single solution, it's a function, guys, a function. Like number 2 here, y is already solved for. You have one solution, as in y is equal to x squared plus 2. That's it. Now, guys, if you go to the first one, you solve for y, you're going to get a compound solution, as in plus or minus. And because you're going to end up with a compound solution, then it's not a function, not a function. Number 1 is not a function. So what in the world am I talking about, guys? What I'm gonna do now is erase the bottom part so I can go ahead and solve that first equation for y. So you can see, guys, it does come out to be a compound equation. And then I will do a specific example to show you why, if you still don't get it, as to why it is a function or not a function. Let me see here. Can you keep this up so I can copy? I walked away for a second. Yeah, man, absolutely, okay? So guys, listen. For number 2, once again, it is a function. Why is it a function? Because in this case, when we solve for y, we get a single solution. So it's a function. The other thing you might want to look at is the power on the y variable. When you solve for y, okay, notice that the power is equivalent to 1. The power is odd. That's another way of determining whether or not this is a function. The power is odd. Whereas with number 1, guys, the power is even, okay? So what I'm gonna do now is to go ahead and solve, okay, that first equation for y, guys. When solving that first equation for y, I'm going to first move the x squared over to the other side. So this becomes y squared is equal to 2 minus x squared. Now you want to take the square root of both sides. When you take the square root of both sides, remember, guys, from the last chapter, we said whenever you take the square root of both sides, you get a compound solution, the square root of 2 minus x squared. And there you are, guys. So what do you notice? There's a compound solution. Now, if that's still not sufficient to prove why this is a function versus not a function, here's what else you can do, guys. Test it out, check it out, plug in a value. For example, in the second equation, if I take 1 and I plug it into the second equation, I get y equals to 1 squared plus 2. So I plug in 1 value, and what do I get? I get 1 value right back. Now let me go ahead and go to the first equation. If I plug in 1, guys, I'm gonna plug in 1, okay? If x is equal to 1, I'm gonna plug it into the first equation. I get 1 squared plus y squared is equal to 2. 1 plus y squared equals to 2. So that would give me y squared is equal to 1 when I subtract 1 from both sides, subtract the 1 from both sides. Now I'm gonna take the square root, guys. When you take the square root, what do you get? You get y equals to plus or minus 1. So guys, listen, I plugged in 1 value. I ended up with 2 values, which means 1 can be paired up with positive 1. It can also be paired up with a negative 1. So what just happened? Here's what just happened. The x's are repeating. For that one x, I have 2 values, which means my x value is repeating because that x value has 2 corresponding outputs, okay? So the domain, guys, is also referred to as the input, and then the range is also referred to as the output. Let me write this down for you guys. The domain is also referred to as the input, and then the range, of course, is referred to as the output. Now, again, guys, what I want you to notice is this. Alphabetically, input comes before output, so input is synonymous with domain, and output is synonymous with range, guys. Now, any questions about this one, guys? Any questions on how to decide if an equation is a function of x or not? Nothing? Okay, guys, so now here's your turn. Here's your turn. Okay, I'm going to write up an equation. Yes or no? Is it a function? Is it a function? Yes or no? Okay. So guys, remember, you will see these questions on the test, okay? Y cubed equals to X plus 2. Function or not? Yes or no? Drop it in the chat, guys. Yes or no? Function or not? Drop it in the chat. Anybody? Not. Moria said no. Anybody else? Jessica said not. Okay, so guys, let's try to solve this for y. And guys, worst case scenario, if you don't know, what do? You plug in a value for x. If we solve this for y, we're going to take the cube root of both sides. How many solutions would we get when we take the cube root of both sides? A single solution. So if you solve for y, you get a single solution. Yes, it's a function. It's a function, guys. Now, if you're still not sure, what should you do? Plug in a value, okay? Plug in a number like, I don't know, I'm just making this up as I go along. Plug in 6. If x is equal to 6, guys, I have y cubed is equal to 6 plus 2. 6 plus 2 is 8. And I'm going to take the cube root of both sides. When I take the cube root of both sides, what do I get? I get 2. So I input an x value of 6 and my output is positive 2 because my one input produces one output. Therefore, yes, it's a function. If it wasn't a function, it wouldn't produce a single output. All right, guys. Okay, I'm a little concerned now, okay? So guys, here's another one. So that one was a function. Here comes the second one. This time, absolute value of y minus 1 is equal to x. Is this one a function or is it not a function? Function or not? Function or not? What do you guys think? Don't be bashful, guys. Just drop something in there. It's either yes or no. Either you're right or you're wrong. It's a 50-50 guess, okay? It's the absolute value of y minus 1 is equal to x. What do you guys think? Sarah says, no, it's not a function. Emily Mato says, yes, it's a function. Okay, guys, so let's check it out. Absolute value of y minus 1 equals to x. Now, this one right here, you know what I'm going to do? I'm just going to plug in a value for x, like x equals to 2. If I plug in x equals to 2, guys, I have the absolute value of y minus 1 equals to 2. Now, remember, we just finished talking about absolute value equations. So when you have an absolute value equation like this, you want to set up two equations. So you guys remember this? So you get y is equal to -1. And then over here, you get y is equal to 3. So essentially, we plugged in one value and we got two outcomes. One input, two outputs. So guys, when we plug in the +2, we're getting a +3 or a -1. So what's happening? The x's are repeating. So therefore, this one is not a function. It's not a function. Why is it not a function? Because we got two outputs. We got two answers for that one input that we plugged into the problem, guys. That's why it is not a function. All right. So here comes the next part, guys. Given a graph, if you're given a graph, you have to determine if it is a function. And this part is easy because you guys have been doing this forever. Determine if it is a function. Now, for these guys, remember, if you're given a graph to determine if it's a function, you perform the vertical line task. A vertical line drawn anywhere on a graph can intersect the graph and at most 1 point, at most 1 point for it to be a function. So a vertical line drawn anywhere on a graph can only intersect the graph in exactly 1 point for it to be a function. So guys, here's a graph. If I were to draw a vertical line anywhere through this point, anywhere through this graph, anywhere, every time I draw this vertical line, it's intersecting the graph once and only once. So therefore, yes. This one is a function. Okay, now look at this next one right here. That's the absolute value graph. So for this absolute value graph, I'm drawing vertical lines through it. Anywhere I draw that vertical line, it's intersecting the graph once and only once. So yes, this one is also a function. Now look at this next one right here, a circle. We are going to be discussing these at the end of the chapter. If I draw a vertical line anywhere on this graph, okay, it just so happens, guys, every time I draw that circle, that vertical line through the circle, notice how many times is it intersecting the graph? Twice. Okay, guys. So because it's not intersecting it once, then this one is not a function. Now, guys, think about it this way. If I were to select a point down here and a point up here, because it's on the same vertical line, they would both have the same x value. So maybe this one is at x1 comma y1, and this one down here is at x1 comma y2. So what is happening? They're sharing the same x value, so the x's are repeating, so therefore it's not a function. So if you are given a graph, to determine if it is a function, guys, you just go ahead and draw a vertical line anywhere through that graph, as long as that vertical line intersects the graph once and only once. Yes, it is a function. All right, guys. Now, here's another major part of this, and that is the function notation, guys. Function notation, once you start talking about it, you will always discuss function notation, guys. So here's the next major part of this, and that is function notation. And when we talk about function notation, guys, it basically denotes the independent variable, of an equation. So essentially, this independent variable right here, guys, is what the equation, the entire equation depends on. For example, if I have y equals 2x plus 3, I know the value of y is going to depend, it's going to rely on the value of x. So I can take this equation and rewrite it as a function of x. So this equation functions on the value of x, and it is equal to 2x plus 3, guys. That's the function notation. So what just happened? Y becomes f of x, or f of x becomes y. So if you're not comfortable with function notation, guys, you can always use y. Y is the same thing as f of x. So keep using the y to represent f of x until you feel comfortable using function notation. The most common function notation you will notice in this class, besides f of x, will be g of x, which you will encounter in this chapter, h of x. But the bottom line is this, guys. You can create any combinations of variables to create function notation. Like distance is a function of time. How far you travel is a function of time, and of course the speed, how fast you're traveling too, okay? So guys, here comes the next part, evaluating the functions. When it comes to evaluating the functions, guys, this is what you're doing, and you will see multiple problems about evaluating functions on the test. So you are given an x value, which we refer to as the input. Let me use a different color here. The input. And then your job is to find the corresponding, you know what, let's abbreviate here, corresponding y value, which we refer to as the output. Okay, so that's what it means to evaluate a function. Now, to be a little bit more precise, guys, I'm going to look at some example problems with you. For example, if we have f of x is equal to x squared plus 2x minus 3, and they ask you to evaluate this function for f of 2. Find the value of the function at x equals to 2. In other words, if I take 2 and I plug it into the function, I input it into the function for x, what's the output? What's the outcome, guys? So I am going to go into the function and I am going to plug in 2. Wherever I find an x value, I'm going to substitute 2 and I'm going to work it out. You can also drop this in your calculators. 2 squared is 4. 2 times 2 is also 4. And then minus 3. 4 plus 4 is 8. 8 minus 3 leaves me with 5. So I input 2. My output is 5. By the way, guys, this is just a coordinate point. X is 2. The corresponding output represents the y value. So 2, 5. That's just a coordinate point. I chose the 2, Sarah, okay? So here comes another one, guys. What's the value of f of negative 3? If I substitute negative 3 into this function, if I input negative 3 into this function, what's the corresponding value of this function? You guys go ahead and try this one. What's f of negative 3 equal to? You guys go ahead and try it and type the answer for me in the chat, please. Okay. What'd you guys get? All right, Emma, Moria, you guys got it. It is 0. So you want to go ahead and substitute the negative 3 in for every single x and then work it out. Negative 3 squared is 9. 2 times negative 3 is negative 6. You minus 3. So all of this simplifies to 0. Absolutely. One more, guys. F of 0, and then we'll take it up another step. F of 0, what would that one equal to? F of 0, guys. What's the value of f of 0? I see negative 1. I see, let me see here, let me see. Negative 3. Yeah, it is negative 3. If you plug in 0, guys, for every single x in this problem here, pretty much the first term cancels out, the second term cancels out, and that leaves you with negative 3. By the way, from chapter 1, guys, you know, I'm not even sure if I really mentioned these, but this one right here where you substitute 0 in and the corresponding y value here is negative 3, we refer to this point as the y-intercept, where the graph intersects the y-axis at 0, -3. We are going to be doing graphing in this chapter, so that is one of the topics we'll be discussing, the y-intercepts as well as the x-intercepts, guys. So that will be coming up very soon. Now, I'm not done with this problem yet, guys, because I have some more I want you to evaluate for this problem. I'm just going to go ahead and rewrite it up here so you can have a fresh version of the problem. X squared plus 2x minus 3. Now, this time around, guys, I want you to find f of negative x. What happens when you substitute negative x for every x? Well, if we plug in a negative x for every single x, for the first term, guys, negative x squared is going to become positive, okay? It's going to become a positive x squared. And if you do 2 times negative x, you get negative 2x, and then the minus 3 is constant, so it remains the same. That's that. Well, what about if it's f of 2a? As in, you're going to substitute 2a in for every single x. What is that one going to simplify to? 2a squared plus 2 times 2a minus 3. So 2a squared, guys, is 2a times 2a. 2a times 2a will produce 4a squared. Then 2 times 2a gives you 4a. And then bring down the minus 3. And just like that, you're done. Now, guys, here's a question you are definitely going to see on the test when you're evaluating the function for f of x minus 1. This one requires a little bit more work, so pay careful attention to it. Now, on this one right here, we're going to substitute x minus 1 in for every single x and working it out. How did you get the 2a? I got lost. Okay, I included the 2a. I wanted you to evaluate the function for f of 2a, okay? I'm giving that to you. All right, guys. So this one right here, we are evaluating f of x minus 1. This is the type of question you could see on the test, guys. So x minus 1 squared, guys, that means x minus 1 times x minus 1. You want to do a little FOIL over here on the side. X times x, x squared. X times negative 1 is negative x. Negative 1 times x is another negative x. And then negative 1 times negative 1 is positive 1. You add these two together, so you end up with x squared minus 2x plus 1. So that x minus 1 squared, guys, it expands to x squared minus 2x plus 1. I'm going to pause here just in case I lost someone, or perhaps you have a question, guys. Are you okay with the x squared minus 2x plus 1, where you are just FOILing x minus 1 times x minus 1? No questions? Okay, let's continue, guys. So I'm going to distribute the 2 over the second parenthesis. So I get 2x minus 2, bring down the minus 3. So now it's just a matter of combining like terms. So I bring down the x squared. I have a negative 2x and a positive 2x. They cancel each other out. And then positive 1 minus 2 minus 3, guys, is going to end up being a negative 4. And just like that, we are done. At this point, guys, you need to think about this problem in the sense that if you were to see this on a test, would you be able to figure this out, guys? Would you be able to find the answer for it? How you guys doing? Okay, I've just got a little bit more to go, and then I'll be done with the lesson, and then we can go ahead and go look at some example problems, guys. All right. So the next part of this, guys, you are given a graph, and you have to determine or find the domain and the range in interval notation. Now, here's the graph. Find the domain, find the range, and interval notation. From this point forward, guys, many times when you see these graphs, you will be asked to find the domain and the range in interval notation. We call that the domain, guys, represents all the x's in the relation. So when they're asking for the domain, they're looking for what is the lowest x on this graph, okay, at which this graph is defined. What is the lowest x at which this graph is defined? And then what is the largest x value on which this graph is defined? So lowest x up to the largest x, guys, in interval notation. Likewise, if we're talking about the range has to do with the y values. So when we look at the y values, again, what is the lowest y value on which this function is defined? Up to the largest possible y value on which this function is defined, guys. That is what you're looking at. So I am going to give you a very tiny example because it's better for me to look at the figures with you guys. Eventually, I'm going to go in and look at examples with you guys. But let me go ahead and do a quick example with you. And I'm going to try my best to make it very precise. And so here we go, guys. I'm going to go ahead and put a vertex right there. All right, guys. So here's a graph. I am looking for the domain and the range of this graph in interval notation. Now, the domain represents the horizontal part of the graph from left to right. This graph is continuous at both ends over here. So it's continuous on the left, it's continuous on the right, which means it continues indefinitely, guys, on both sides, on the negative side of the x-axis as well as on the positive side of the x-axis. So there's no restrictions in the domain of this function. So therefore, the domain of this function would be from negative infinity up to positive infinity. Why? Because this graph is continuous on the left and it's continuous on the right. Now, the range, on the other hand, is another case altogether. The range, guys, is the vertical part of the graph, the part of the graph that goes up and down, okay? So in the case of this problem right here, guys, the graph starts down here, right here at this point. This is the lowest y value on this graph where the graph is defined. What is that lowest y value? It's at -1, -2, -3 right here. So that is the lowest y value. And guys, because it is on the graph, we want to include that -3 with a bracket. And then guys, what happens after that? The graph increases on the right indefinitely. It increases on the left indefinitely. Where is it increasing to? It is increasing to positive infinity. So this would represent the range, guys. Any questions? If this is the first time you're seeing this, guys, it's going to take you a good 3 to 4 examples for you to really figure it out. I'm gonna do one more, guys, like this. I'm gonna do one more. So here's the XY plane again. I'm gonna sketch out another figure, all right? And this time I think I am going to do an absolute value, okay? So in the case, ooh, let me use a different color. There we go. Now, by the way, guys, is this one a function? What do you think? Is it a function? Nope, you're right, Emma, very good. Okay, how do we know it's not a function, guys? Vertical line test. If you draw a vertical line anywhere on this graph, notice the vertical line is intersecting the graph more than once, so therefore it is not a function. Now, everyone, let's look at the domain. The domain represents the lowest x on this graph where it is defined. You notice the graph starts right here, guys. So this would represent the lowest x on the graph. What is that lowest x value? It's at -3. And because it is on the graph, we're going to use a bracket with the -3. And then the graph continues to the right, increases to the right, okay? Because the domain has to do with the horizontal part of the graph. So the graph is steadily increasing to the right all the way up to positive infinity. And that's it, guys. Remember, infinity always uses parentheses. Now, let's talk about the range. The range, everybody, is the vertical part of the graph, up and down, vertical part of the graph. So what do we notice about the range? Over here, on the negative side of the y-axis, the graph continues indefinitely. Over here, on the positive side of the y-axis, it continues indefinitely, meaning there's no restriction on the domain of this particular graph. So therefore, guys, the range for this one will go from -infinity up to positive infinity. And there you are. Any questions, guys? No? All right. So we're almost done, guys, almost done. I've got 2 more topics to mention to you, and then we'll go and look at some example problems from the assignment. Intervals on which a function is increasing, decreasing, and constant. So guys, when we talk about the intervals on which a function is increasing, when we talk about the increasing part of the function, we're looking at the y values. And in that interval over which it's increasing, we're looking at the x interval over which it is increasing. So when you write these intervals, guys, you're writing an x interval. So here's how you approach this, guys. For the increasing part of the function, the interval on which it's increasing, you have to ask this question. What is the lowest x value where this graph starts to increase? as in the y values are getting larger and larger. What is the lowest x where the graph starts to increase? And at what values, at what x value does it stop increasing? At what value does it stop increasing? By the way, guys, when you're writing these intervals, notice I'm mentioning x because you're looking for an x interval. You do not include, guys, the boundary values. Do not include the boundary values. You want to use parentheses for these intervals. Do not include them. Do not use a bracket. So likewise, guys, if we're looking for the interval on which a function is constant, again, ask this question. At what x value does this function become constant? As in it becomes a straight horizontal line. And then up to what x value does it continue to be a constant? At what x value does it stop being constant? And then finally, the decreasing side of things. Okay, I am going to show you guys an example in a minute, so just hang on. Okay, the decreasing side of things, guys. So let's look for the decreasing side of things. Same thing. At what x value is the point at which the function starts to decrease, and then at what x value does it stop decreasing? So that is how you write the intervals. You do not include the boundary values, okay? Okay. Hold on, let me see here, Inaki. All right, I'm almost done, Inaki. Can you hold on, please? Because I don't want to interrupt this and then have to go get the code because I have to go get it from another screen. I'm almost done though, okay? So guys, here we go. On this one right here, I am going to go ahead and just create a function, and then we're going to find the intervals on which the function is increasing, decreasing, and constant, guys. So on this one right here, let me see, I am going to start down here, and let me see here. Oh, this is horrible. I'm trying, guys. Okay, how about this? Let's do this. Make it as easy as possible on me. All right. I think that should do it. Okay, maybe I should have used a different color right here. Let's use a different color, guys. So guys, here is your function. This one is a function. There's your graph. So now, guys, we're going to figure out the intervals on which this function is increasing, decreasing, and constant. And when I do this, guys, I like to go from left to right because when you're graphing, you're always going from left to right when you're graphing. So guys, on the left side, we're looking at the interval on which this function or this graph is increasing. This graph starts to increase over here, guys. What I want you to notice is this. This is continuous. And because it's continuous, it is starting to increase from negative infinity, and it continues to increase up to about this point. At this point, what is the x value where it stops increasing? The x value right there is at -3. So the interval on which this function is increasing goes from negative infinity up to -3. Okay, notice I am not including the -3. Additionally, guys, let's look. At what interval is this function constant? Well, let's look. Constant is the part where the function is on a straight line or a straight horizontal line right there. It starts becoming horizontal. It starts becoming constant at this point right here. At this point, what is the x value? The 3. And it continues steadily to be constant up to about this point. At this point, what is the x value? The x value is at +4. So it continues to be constant up to +4. And then the last part of the graph, guys, is where the graph is decreasing. And the graph is decreasing over here on the right. It starts to decrease at this point. At this point, what is the x value? +4. You do not include it. And it continues to decrease indefinitely to infinity, guys. So these are the intervals on which this function is increasing, decreasing, and constant. Okay, Sarah, look at it this way. I am going to do another one, but I'm going to go to the assignment to look to do another one. When we talk about the graph increasing, it's sloping. It's got a positive slope. That's another way for you to look at it. Okay, so over here, when I started out, the graph is increases. It's starting over here. When you draw a graph, you draw it from left to right. So over here, it's starting to increase, as in the y values are getting larger and larger. So down here, we have a whole bunch of negative y values. Once we pass the x-axis, we get into the positive side of the y-axis. So over what x interval, okay, is this function increasing? And then over here, notice that the graph flat lines. When it flat lines, we call this the section of the graph where it is constant, because the y value is not changing, it's remaining the same. So at what x values is this function constant? Well, it's constant starting over here at x equals to -3, and it continues to be constant all the way up to here at x equals to +4. So from -3 to 4, y is the exact same number. What is that one number? 2. It's constant. It's always the same number regardless of what the x value is. And then last but not least, Sarah, on this side of the graph right here, this is where the graph is decreasing. So the slope is decreasing. The y values, they start out to be positive y values. And then over time, over this interval here, it's decreasing and getting smaller and smaller to the y values. So the y values are getting smaller and smaller. That's what this is about. We are going to do some more examples. Just hang on. And guys, here's the last topic, and then I will stop the recording so we can go ahead and go into the assignment. Now, remind me to get that code, guys. Relative maximum, and of course, relative minimum is where we're going to stop. And guys, the best way to express this is through a little figure. Now, for the relative max, the relative min, let me just go ahead and quickly explain it to you rather than having to write everything down. When we talk about relative max and relative min, guys, the relative max, okay, listen to this part, represents the highest point in a graph relative to the points around it. So in other words, people like to refer to it as a peak in the graph. So right here, you have a peak in the graph. This would represent a maximum point. So let's say this maximum point is at A, comma, B. So then if they were to ask you for what is the relative max? The relative max, guys, would be the y value at the point right here, at the highest point. The y value at the highest point. That's what this is about. So likewise, if they were talking about the relative min represents the lowest point on a graph. In other words, the valley in the graph, and remember, this is only relative to the points around that relative min. And the reason we say relative, guys, is because notice this graph keeps decreasing. It's getting smaller and smaller on the left. It's decreasing to -infinity on the left, and on the right side, it's increasing to +infinity. So this is not definitely the highest point on the graph. It's just a relative maximum of the graph because the graph continues to increase. But in regards to the points around it, this is relative. This is the relative max. And then in regards to the point around the relative min, this right here would represent the relative min because, guys, this is not the absolutely lowest point on this particular graph. So guys, if this coordinate point right here were at, let's say C, comma D, let me use a different color here, C, comma D, if they were to ask you, what is the relative min of this graph? The relative min would be the y value at that point, and so that would be the D, guys. So there's a relative min at D. So bottom line, relative min has to do with the lowest points on the graph in relation to the points around it. Relative max has to do with the highest points in relation to the points around it. Whenever we talk about relative min, relative max, guys, they always occur, they happen at the turning point. There must be a turning point. If there's no turning point, then you will not have a relative min or a relative max. You must have a turning point in order to potentially have a relative max or a relative min. And if they ask you for the relative max or relative min, they're asking for the Y value at the turning point, the Y value at the turning point. So guys, be careful with this. Read the questions, understand what the question is asking you. And as I said, I am going to be going over some example problems very shortly. And yes, these are the type of questions that you will see in the assignment, guys. So I am going to pause here and I am going to stop the video and get your attendance code, and then we'll go ahead and go into the assignment together, guys.